Hello everyone, my name is Alex Tomsic. I'm the Director of Engineering for Red Wolf Reliability. This is the next video in our series on our Voyager FDS sensor. Today we're going to provide a quick overview on the installation of the sensor. So for our example today, we're going to just show a quick mock-up showing some sensors that are installed on a plain cylindrical journal bearing, and we're going to talk about sensor mounting locations and orientations. So just to serve as a little bit of a review, the images on this slide show a plain cylindrical journal bearing. The image on the left, if you remember from the last couple videos, shows the operating position during a startup of our plain cylindrical journal bearing. Remember, our rotor will lift initially and then it moves over with the direction of rotation as it raises up. And that creates that attitude angle we talked about in the last couple of videos. The oil that supports the shaft in this situation develops a pressure based on where the static load of the shaft or on the shaft exists in that bearing. So for our plain cylindrical journal bearing, we'll actually develop high pressure right below the shaft at that bottom dead center location. That's shown by the animation on the right. Remember, we're installing Voyager FDS sensors and we want to measure dynamic strain. It's important for us to make sure we can measure strain where that high oil pressure exists. So on a plain cylindrical journal bearing, we would install a sensor at the bottom dead center location straight below the shaft. And then we'd also install a sensor at 45 degrees with rotation just on the opposite side of that slanted green line on the animation on the right. So here we have a mock-up of a plain cylindrical journal bearing with two Voyager FDS sensors installed. The first sensor is mounted at the bottom dead center location. You can see that that sensor is directly below the shaft, and the other important thing is the arrow on the sensor, which denotes the measurement direction of the sensor, is pointed directly towards the shaft center. Okay. The other sensor, which is at 45 degrees with the direction of rotation from that bottom dead center location, is also in the proper location and orientation. The purpose of this second sensor is it can provide some more diagnostics abilities by comparing the amplitudes of the bottom dead center sensor and the 45 right sensor. So then in this situation, we can see that these two sensors are installed on the same bearing, but the locations that they're installed at and their orientations are improper. So as you can see, the bottom dead center sensor is in the right location. It's still at that bottom dead center location that we would recommend, but you can see that it's turned 90 degrees and the arrow or the measurement axis of the sensor isn't pointing towards the bearing center. This would lead to amplitudes that are somewhat erroneous as they're not directly related to the movement of that shaft and the load that's transmitted down through that bearing by that high pressure oil. Additionally, the other sensor is in the wrong location and has the wrong orientation. So you can see that right sensor is only 30 degrees away from the bottom dead center sensor in the direction of rotation, and its measurement axis isn't pointing towards the center of the shaft. So these two sensors would give improper data based on the conventions that we've laid out. So it's just important to remember you need to make sure that you know where to mount the sensors and that those sensors are always pointing towards the middle of the shaft. All right, everyone, thank you very much for watching this video. I know it was a quick one. The next video in this series is actually going to go into the installation procedure of the Voyager FDS sensor, so please keep an eye out. And if you haven't watched any of our other videos, please check them out on our website at voyagerdynamics.com. Thanks so much. Bye.